All right, so we're going to walk through the solutions to the word problems that you were assigned for homework on Wednesday and were due on Thursday. So Stan's house is located at the top of the hill, but the driveway is located on the bottom of the hill. When he parks his car, he can see the base of his house when he's looking at an angle of 42 degrees. When looking at the top of his house, he does so at an angle of 55 degrees. If where he stands is 48 horizontal feet from the base of the house, how tall is this house? Round to the nearest foot. Okay, so basically, all right, we have the base, we have the top. And this is what we got. It's basically going to be two different right triangles. So it says where he stands is 48 horizontal feet from the base of the house, so that's 48. This is 42. This is 42 degrees. Now keep in mind, this is not 55. The whole thing is 55. So that part would be 13. It's very important. All right. So when we want to figure out the distance to the base, let's call it x. Again, hypotenuse aren't involved, so it's going to be tangent. So tangent of 42 equals the opposite, which is x, over the adjacent, which is 48. To get the top of the house, instead of 42, it would be 55. So tangent of 55 equals x over 48. That doesn't change. All right, in both cases, what am I going to do? Well, I'm dividing by 48, so I multiply. I go to my trusty calculator. All right. And I realize I'm multiplying, so I do 48 tangent 42. Comes out to be about that. And then I do 48 tangent 55. It comes out to be about that. So I have 43.22 feet, 68.55 feet. That's the distance, the vertical distance to the top. That's the vertical distance to the bottom. How are we going to find the height? We're going to find the difference. We're simply going to subtract 68.55 minus 43.22. And I end up with about 25.33 feet. All right, so we got a house that's 25 feet tall. All right, next one, shadow problem. It says a 6-foot person standing 20 feet from a street light cast a 10-foot shadow away from the street light. What is the height? Ooh, sorry. That was crackers for my lunch. What is the height of the street light round the nearest inch? So, 6-foot person over here, standing 20 feet from a street light. Boom. Cast a 10-foot shadow away from the street light. What is the height of the street light around your nearest inch? All right. So this is 10. All right. That's basically what we're looking at. All right, a shadow problem kind of is two similar triangles on top of each other. All right. So basically what we can do if we want to use trig, all right, is we can find this angle. Tangent of the angle is 6 over 10 equals 3/5. Again, I go to my calculator, second tan, 3/5, which is 0.6, and you get about 31 degrees. Now we go back and get the height of the street light. 10 plus 20 is 30. So now we're doing this problem, 30, 31 degrees, trying to get the height. Again, it's tangent. So tangent of 31 equals h over 30. Just like in the previous problem, the variables in the numerator, numbers in the denominator. So we multiply 30 tangent 31. Remember to be in radians. It's 18.02 feet. Now we need to round to the nearest inch. We need to round to the nearest inch. So to do that, this is what I would do. They're giving it to me in a decimal, so I get rid of the feet, and that's 18. So 0.025. I'm going to multiply that times 12, and I get 0.3, which is not even an inch. It's not even a half an inch. So if I rounded it, it would round down. So it's actually going to be 18 feet when I get my final answer. Number 3, 20-meter line is used to tether a helium balloon. Because of a breeze, the line makes an 85-degree angle with the ground. What is the height of the balloon round to the nearest centimeter? All right, so I got a high triangle rather than a short, wide triangle. All right, so this is the 85-degree angle they're talking about. This is the 20-meter line they're talking about, and that's the height we're talking about. Opposite over hypotenuse, we all know hopefully by now is sine, so sine of 85 degrees equals h over 20. Hopefully from previous problems you realize that because the variable is in the numerator, we're going to multiply 20 sine 85. And I got h to be approximately 19.92 feet. Wait, this was in meters. So that's 19.92 meters. Okay, they want us to round to the nearest centimeter. So that's 19 meters, 92 centimeters. All right. On the back, a 100-foot ladder, the sliding ladder problem. I love this problem. A 100-foot ladder lies against the house. The base of the ladder lies 28 feet from the base of the house. The top of the ladder slides down 18 feet. So we got two different situations. In the first one, the ladder is 100. The base of the ladder is 28 feet from the house. Okay? So now, okay, I can either use triples or Pythagorean theorem. This comes out to be 96. All right? Again, I can either use triples or Pythagorean theorem to do that. 28 squared plus b squared equals 100 squared. Or take the 7, 24, 25 triple. 25 times 4 is 100. 7 times 4 is 28. So 24 times 4 is 96. All right. It then says the top of the ladder slides down 18 feet. Well, if I'm at 96 and I slide down 18 feet, that's 78 feet. Okay, this is still 100. All right. This is still 100. We're trying to figure out this. All right. So we're going to go once again do Pythagorean theorem. 78 squared plus b squared equals 100 squared. 100 squared minus 78 squared raised to the square root, and it comes out to be about 62.6. Okay. What's the total change then? About 34.6 feet. Notice it's not 18. What is the change in the angle measure that the ladder makes with both the ground and the house? So I'm going to make that x and that y. And since we haven't done a lot of it today in these word problems, I'm going to use cosine. So cosine x equals 28 over 100. So I'm going to go to my calculator and do second cosine. 28 divided by 100, or 0.28, and that comes out to be about 73.7 degrees. Now I'm going to do the same thing over here. I'm going to use the 62.6 and the 100. Actually, you know what? I'm going to use sine for this one because that's an exact value. So sine of y equals 78 over 100. So I'm going to do second sine. All right. Of 0.78. I'm going to get about 51 degrees. 51.3 degrees. I'm going to stay consistent. So I started at 73.7, 51.3. I end up with 22.4 degrees. All right, now, if I did the same thing with those angles, guess what? It would still be 22.4 degrees. The reason being, if that angle increases to balance it out, that angle would have to decrease. So the change is going to be the same because those two are 90. So the other two angles of the triangle are always going to balance each other out. Guy wire runs from the ground to the top of a 25-foot telephone pole. The angle formed between the wire and the ground is 52 degrees. How far from the base of the pole is the wire attached to the ground? All right, so there's my telephone pole. The angle formed between the wire and the ground is 52 degrees. How far from the base of the pole is the wire attached to the ground? So there's the base of the pole. We're trying to figure that out. Once again, it's tangent. Tangent of 52 degrees equals 25 over z. The difference is now the variable is in the denominator. So instead of multiplying, we divide. We end up doing 25 divided by tangent 52. And I get myself approximately 19.5. So it's going to be about 19 and a half feet. All right. And then the last one in that homework, find the area of the triangle below around the nearest square millimeter. All right. So first off, since we're doing millimeters, you may want to change that to 75 millimeters. It's going to make your life a whole lot easier. All right, rather than converting at the end where you got to remember to square your conversion factor. So H is GA. H is opposite of 38. The 75 is adjacent. So once again, I'm going to go with tangent. So tangent of 38 degrees equals H over 75. When I do 75 tangent 38, I get 58.6. That's 58.6 millimeters. All right. Now, this is a 90-degree angle. Angles of a triangle add up to 180. This is also a 90-degree angle. These angles, remember from geometry, always add up to 180. So this one's got to be 52. This one's got to be 38. I need that because they didn't give me another side length over here, so I need an angle measure. All right? So if I use the 38 and I want to get this, x, okay, that's opposite, that's adjacent, so once again it's tangent. Tangent of 38 equals the opposite, which is x over 58.6. I do 58.6 times tangent 36 times tangent 38, sorry. And I get 45.8. And my last step is to find the area of the whole thing. To do that, I do area equals 1/2 base. So I'm going to add these together. I get 120.8. The height, which I got in the first step, was 58.6. Once again, I go to my trusty calculator. And I get approximately 3,539 millimeters squared. All right, and that's a wrap. So those are the solutions to the word problems. Keep working today on the review. Again, it's optional, but if you have any questions, feel free to drop me a line or join the virtual math lab at 2:15. Either way, best of luck and A's will see you Friday for the quiz. B's will be taking the quiz from home. And then you guys will switch the next time.